Welcome back for the fourth lesson of 3ds Max. Let's get right back into our first steps in the software by illustrating the fundamental concepts behind managing the objects in the scene, moving, rotating and scaling. To better understand these simple but important tools, I've created a simple object in the scene, suitably displayed in wireframe mode to allow you to fully understand what we are about to see. Let's immediately refer to the highlighted area of the toolbar to see which tools will be covered in this lesson. And we'll begin by activating the move command. And try to understand how to interpret the gizmo shown in the scene. As you can see, the viewports, as well as showing us where we are viewing the viewport from, also represented Cartesian planes of reference on which objects move. This little three-pointed gizmo is simply the graphic representation of these reference axes. Therefore, by left-clicking on axis to select it and then dragging, we move the object in the direction of that axis. Note that when the mouse comes near an axis, the axis lights up and is selected. When we click, the axis is locked and the object is forced to move only in that direction, forward or back. If instead we move the mouse to the central area, shared by the different colors of two axes of the plane, and click, the whole plane is selected and the object can move freely in both directions along the two axes. So, to simplify, we can say that by moving the object on the XY plane, the object moves along the plane in the top view. By moving the object on the X plane, the object moves along the plane in the front view. And by moving the object on the ZY plane, the object moves along the plane in the left view. You should note that by default, if we click on each individual orthographic view, the axis of reference always changes to XY. For the top view that's normal, but the same goes for both the front and the left view. It isn't an error, but relates to the type of reference coordinate systems we are using. By default, Max uses the view type, which identifies the axis XY as relative coordinates for the view that's active at any one time. It doesn't really change the axis, rather it uses XY for convention's sake. Let's say, if instead we want Max to always use the same reference axis for each individual view, we have to choose the word system. You can choose the mode that best suits you. It's a much simpler matter for rotation. From the toolbar, we access the tool by clicking on the icon shown. In this case, the gizmo has a different appearance, but there's no need for alarm. It's actually very simple. If we bring the mouse towards one of the colored axes, in fact, the system identifies which axis the rotation is occurred around. By dragging, the object can be rotated both in one direction and the other. Just like before. The color blue identifies the rotation axis Z, the color green the rotation axis Y, and the color red the X axis. Let's move on to scaling. We select the highlighted icon and see that again the gizmo has a new form. But, just like before, it's the same thing. We can only scale the object by pulling it along an axis, widening and tightening in only one direction. Or we can scale it, pulling it along the two directions of the plane of reference by clicking and dragging on the outer part of the tool. Finally, we can scale it evenly in all directions by clicking and dragging on the inner part of the gizmo. This way, all the axes and all the planes will be active in the change to the object. To finish off this lesson, let's look at what the pivot point is, what it does, and how to manage it. The pivot point is quite simply the linchpin of an object. That is the point around which all move, rotation, and scaling operations are carried out. This pivot is found at the exact point of intersection of the axis and is highlighted in the image by the red mark. So let's look how to manage and change this pivot point. Customarily, when a basic object is created in a scene, the pivot point always coincides, or almost always, with the central point at the base of the solid. If, for example, we activate the rotation tool and try to rotate the object, we'll see that the pivot around which the object is rotating is precisely that point. So let's change the position of this pivot, and to do so we are going to dive into another section of the command panel, the Hierarchy tab. In Pivot, we can make adjustments on the pivot point by clicking on Effect Pivot Only. Then, selecting the object and the Move tool, we can change the position of the pivot depending on our needs. To make the changes more effective, we click again on Effect Pivot Only. And this is the result. If we need to place a pivot exactly in the geometric center of an object, we can easily do by reactivating Effect Pivot Only and then clicking on Center to Object. We may also leave the pivot point in its starting position but move the object. We'll look at it in a moment. Now, for technical convenience, I'll quickly move the cube back to its starting position. This time, instead of clicking on Effect Pivot Only, we click on Effect Object Only. Now we move the object away from its pivot point, placing the pivot point outside the object. As you can see, the pivot point remains in its position and the object moves. This tool is indispensable above all for cloning a series of objects, but we'll talk about this and much more in the next lesson. That's all for now. I strongly advise you to try out the things you've learned in this mini course over and over. Bye.